For decades, some of the smartest engineers on the planet tried to build useful robots, and they failed. Not because the idea was bad, but because the world kept breaking them. Billions of dollars were spent. Thousands of brilliant people worked on the problem. Entire companies were founded on the promise that robots would soon transform our lives. And for 30 years, almost nothing worked outside of a factory. The question isn't why robots are suddenly everywhere. The question is, why did it take so long? Let's be clear. Robots aren't new. Japan had industrial robots in the 1980s. Car factories were automated before most people had email. Those machines were incredibly precise. They could weld the same part 1,000,000 times without a mistake. But they were also trapped. They could assemble a phone, but they couldn't walk across a room. They could follow perfect instructions, but they couldn't deal with change. At the same time, software was moving fast. The internet happened, smartphones happened, cloud computing, search engines, social networks, progress everywhere. But robotics stayed slow. So what made robots different? Why couldn't we just apply the same progress we saw in software to machines in the real world? That's what made it so frustrating. It wasn't a lack of effort. Some of the best minds in computer science spent their entire careers on this problem. Universities built robotics labs. Companies like Boston Dynamics created machines that could run, jump, even do backflips. And yet, when it came to being useful outside controlled environments, robots kept failing in the same ways. They couldn't handle variation. They couldn't adapt. A robot that worked perfectly in the lab would fall apart the moment you changed the lighting, moved an object slightly, or introduced anything unpredictable. And that failure came from how robots were built. Traditional robots were programmed. Every movement, every decision, every response had to be written in advance by an engineer. If a robot needed to grab a cup, someone had to code the exact angle, the exact grip strength, the exact path its arm should follow. That worked fine if the cup was always identical, always in the same place, under the same conditions. But the real world isn't like that. Cups come in different shapes. They're placed differently every time. The lighting changes, surfaces aren't perfect, and every new variation required more rules, more exceptions, more code. Complexity exploded. Engineers were trying to describe an infinite, messy world, one instruction at a time. It was never going to scale. The world is messy. Robots couldn't handle that. For decades, nothing really changed. And then, in just a few years, everything started to move. In the 2000s, a few research labs began approaching robotics in a completely different way. Instead of programming robots with explicit instructions, they let robots make mistakes. A lot of mistakes. A robot would try to pick something up. It would fail. It would adjust. It would try again. And instead of engineers fixing every failure with new rules, the system learned from experience. This was the turning point. Robots stopped being programmed. They started being trained. That shift unlocked everything. Because what changed wasn't the hardware. It was how robots learned. AI gave robots something they never truly had before: the ability to deal with uncertainty. Deep learning transformed perception. Robots stopped relying on perfect measurements and started recognizing patterns. They could identify objects even when conditions changed. Perception wasn't about precision anymore. It became about probability. Reinforcement learning changed action. Instead of being told every move to make, robots were given goals. They explored. They failed. And over time, they discovered strategies that worked. Simulation made this scalable. Robots could train in virtual worlds, running through millions of scenarios in compressed time. By the time they reached the real world, they had already experienced more variation than any traditionally programmed robot ever could. AI didn't make robots perfect. It made them adaptable. And that's why robotics suddenly feels like it's everywhere. Warehouses filled with autonomous systems. Logistics powered by machines that can handle chaos. Serious investment in humanoid robots. Companies didn't suddenly become optimistic. The fundamental bottleneck disappeared. The difference between 2010 and today isn't that we built better machines. It's that we stopped trying to predict every possible scenario and started building systems that could learn their way through them. Robots didn't suddenly improve. the bottleneck disappeared. And once you understand that, you start to notice the same pattern everywhere. Progress doesn't always look like steady improvement. Sometimes, it looks like decades of failure followed by a single shift in approach. The question was never whether robots could work. It was whether we were solving the right problem.